can transmit if it is a single V butt weld or if it is a double V butt weld. Okay. So the permissible tensile stress of the plate is this much. Okay, that is fine. Considering factor of safety. So the factor is already considered in this value, so we don't have to apply factor of safety separately for this problem. Now, what is single V butt? So here we have two plates. We have a butt joint. If it is single V butt, then we are joining it this way. Okay. So this is our welding, and it is a single V weld. So if it is done on both sides, it is going to be double V. Okay, that's what it means. If it is double V, the entire section is welded. Okay. If it is single V, not the entire section is welded. There might be some gap. Okay. There might be some gap at the end if it is a single V. So that is our difference between double V and single V. Now, thickness of the thinner plate is 10 mm. And according to that, we have to consider what is the throat thickness of the joint. Okay, we consider that this is 5/8 of T1. What is T1? T1 is the thickness of the thinner plate. We have two plates, one is 12 mm thick and one is 10 mm thick. And then we have a single V butt weld. Okay, this way. So there might not be complete penetration, there might not be complete joint between the two plates. Therefore, we consider the throat thickness to be this one, not the entire thickness of the smaller plate. Obviously, it has to be corresponding to the smaller thickness, but not the entire thickness of the smaller plate itself. 5/8 times of the thickness of the smaller plate. So we have to remember this factor. What is this value? This value is the allowable tensile stress. That is 150 megapascal or 150 Newton per mm square. We are dividing it by 1000 to make it kilonewton. And what is W? Is the width of this plate. Okay, the width of the plate, 180 mm width of the plates. So this is the allowable stress, and this is the area on which welding is there. This is the allowable stress in Newton per mm square, and this is the depth of the weld, and this is the width of the weld. So these two is giving us the area of the weld multiplied by the allowable stress. That will give us the load it can carry or load it can transmit. Fine. So we have this allowable stress in megapascal, that is Newton per millimeter square. So if I divide this value by 1000, this will come in kilonewton, because otherwise the value will be in Newton. So I'm dividing it by 1000 to get the value in kilonewton. So this much kilonewton the joint can transfer, or the joint can carry safely, right? Again, going to the condition 2, if it is a double V butt weld, what will be the value? Now, same thing, the area of the weld multiplied by the permissible stress. Now, we are not applying any factor of safety here because it is already told in the question that the allowable stress here has been taken after considering the factor of safety. Okay, so it's very easy. We just have to see the area of the weld and we have to multiply it with the permissible stress. Newton per millimeter square, the area of the weld, sorry, permissible stress, and the area of the weld in millimeter square will give us Newton. And that Newton is being divided by 1000 to give the value in kilonewton. Now, 150 Newton per mm square or megapascal is the permissible stress already. Now here we are taking T as the thickness of the smaller plate, which is 10 mm, and this is the width of the plate. Now why we are taking T as 10 mm? Because this time we have a double V. Okay, we have a double V. Okay, here we have, and here also we have. So we have completely welding in every area. Okay, so the thickness of the thinner plate or the smaller plate is going to be the thickness of the weld. Fine, or depth of the weld, and multiplied by the breadth, which is 180 mm. This gives us the area of the weld, multiplied by the allowable stress will give us the value in Newton, and that value we were dividing by 1000 to get it in kilonewton. That's it. So in the first case it was only 1.75 kilonewton, and the second case it becomes 270 kilonewton. Okay, then I hope this is clear. This is very easy, the first problem. Then we go to the second question. In the second question, we have a tie member. What is a tie member? A member that is carrying tensile force. That is a tie member. If it is called strut, then it is a member which is carrying compressive force. Okay, struts are like columns, but they are not vertical. They may be in any angles inclined to the horizontal. Now we have two channels, IS and C. Okay, Indian Standard Medium Channel 200. That means 200 is the depth of the channel section. Back to back required to connect to a gusset plate. Which is a gusset plate? This one is a gusset plate. Now this is a channel section. Now this is connected to the gusset plate. Now design the fillet weld. Now we have to design a fillet weld joint to develop full strength member. Overlap is limited to 400 millimeters. So this is the overlap, 400 mm. It is limited to 400 mm only. This depth is 200 mm. This is the ISMC 200. As the name says, that depth is 200. It's like this channel section. This is 200. Now, what else we have? Assume permissible stress in the weld is 108 megapascal and permissible stress in the section is 150 megapascal. Now, let's see what we can do. So the properties of this channel section, thickness of the web. Okay, now these are from steel table. I hope you know what is a steel table. In the steel table, according to different channel sections or I sections or T beams, whatever sections we have, whatever is their thickness, their weight, etc., everything is given in the steel section. So whenever we are doing properties, numericals based on these properties of the channel section or I section or T section, we have to refer to the steel table. For your case, you may get the soft copy or hard copy, whatever you want. You may get that one, but the values, if it comes in exam, the values will be provided. Don't worry. This is coming in final exam. And from where we have to get it? We have to get it from the standard steel table. So these values, the cross-sectional areas, the thickness, thickness of flange, thickness of width, web, everything we are getting from the steel table. Okay. If it is the I section, then what happens? This is our flange and this is our web, right? This is our flange and this is our web. If it is a channel section, then this is going to be our flange and the middle portion, this is going to be our web. Then now the tensile strength of channel section. Sigma AAT, this is the allowable one, right? And then we have the AST. Okay, what is the area of the section? This is 2821 millimeter square. That is the area of the section, and the permissible stress 150 Newton per mm square will give us the value in Newton, and then it converted into kilonewton by dividing by 1000. We know that already, right? Now, here in this case, the minimum size of the weld will be 4 mm. Now for this we shall have to go to IS 800. In IS 800 the sizes of the welds are given. I'll tell you where later, we'll see. In IS 800 the minimum sizes of the welds are given. Minimum sizes of fillet welds are given according to the thickness of the plates that are being joined. Okay. Now in this case the condition is that we have minimum weld size is 4 mm and maximum weld size is 6.1 minus 1.5. 6.1 is what? The thickness of the web. Okay. We are connecting. Here, this portion that we see here, these are the flanges of the channel section, and this middle portion is the web, and we will have connections here, right? So we are considering this value 6.1 minus 1.5, 4.6 mm is the maximum weld size, and we have to provide a weld size of 4 mm. We are considering the minimum weld size. Now, again, there is another concept. What is effective? Discuss these things. I hope you remember. Effective throat thickness. Now, this is the fillet weld is like this kind of triangular. Okay. This is the S. This is the size of the fillet weld. Okay. And this portion is the throat thickness. Okay, this portion is the throat thickness. So this value is equal to 0.7 s. When again there is another condition in IS 800, we get these conditions when this angle of the fillet weld is 90 degree. When this is a 90 degree here, it has to be 90 degree at this location. Okay, then it becomes equal to 0.7 s. Actually this value is ks, and the k factor is 0.7 for a fillet weld of 90 degree. Okay, then we will find out what is the strength of the weld per millimeter length. Okay, what is the strength of the weld per millimeter? 108 is given to us as per the question, and this is the throat thickness. Okay, so this is the value per millimeter length. Now, what is our required weld length? Now, tensile strength of each channel section. This is the strength of the channel section. In the question, we have been asked that we have to design a joint so that there is a full strength development. So we have to generate a strength capacity equal to this value. Okay, equal to this value. This is the strength of the channel section. So we go back to generate this much value. How much millimeter length we require? This much kilonewton we have to develop. This much kilonewton is developed per millimeter. So we are dividing it, and we are trying to find out how much meters of welding shall be required to develop the full strength of 423.15 kilonewton. So this much is the value coming out. Now, how shall we do this? Okay, so this is the connection initially, right? And we have been told that the maximum overlap allowed is 400 mm overlap of the channel section with the gusset plate. This is our channel section, and this is our gusset plate. Okay, so the maximum overlap is 400 mm only, it is told. So we see how much space we have. 400, 200 mm is the depth of the channel, and mm again here. So 400 into 2 plus 200, we see that we have only 1000 mm allowed. Okay, we have only 1000 mm allowed length. but the length that we require is 1399 mm. So what we have to do, we have to provide slots. Okay, so we have to provide slots like this. So what we are doing cutting here so that we have increased length of the weld. Okay, so this is called slotting. This is done to increase the strength of the welding joint. By doing this, what we are doing, we are increasing the length of the weld, and eventually the strength of the joint is being increased. Okay, so here these are some conditions according to the IS code. Okay, this is called W here, and this is called D here, and this is A, right? So these three parameters we are checking out. So W, how much we are considering? 25 mm, it is greater than 3D, it's okay. D is 50 mm, we are considering greater than 2D, okay. And finally, if we do the calculation, we see that A is coming out to be 100 mm. So this way, if we provide, we can get the required length, and this length is required to develop the full strength this much. Okay, and this was the value per millimeter from where we were getting this value by multiplying the strength of the weld with the throat thickness. Throat thickness is 0.7 in S is the size of the weld. Why is 0.7? It is a factor. It depends upon the angle of the weld. In our case, we are considering 90 weld here. So this factor becomes 0.7. There are other values for other angles in the IS code. Okay, the IS 800 gives values of K as per different angles of fillet welds. And then again, we will finding out what is the full strength, what is meant by the full strength. It is the strength of the channel section. This was given to us, that is the allowable stress in the plate channel section, and this was the area of the steel. Now this we were getting from steel table. Now if you have steel table, it's good. If you do not, you can get a soft copy, or for exam point of view, these values, if required, will be provided along with the question. Okay. So after this, what is a gusset plate? Okay, so here if we see, this is one member, there is another member, and there is another member. Now these members are joined by this plate. Now this plate is known as gusset plate. Okay, so the gusset plates are used at the joints to connect different members here. Okay, this is another type of connection. This is another one type of connection. Our main objective is to recognize what is a gusset plate. This is one. This can be an L section, and here we have a gusset plate which is connecting all the three members. Okay, so this is one angle section, and this is one lug angle. Lug angle is a small angle section, and this is this type. If we look, okay, so small angles section which is used for the connections. Okay, that's it for the joints. Okay, so lug angle, you see here from the sectional view will be like this, and if it is good side view will be like this. It is used at the joints. Okay, and this one plate, this plate is the gusset plate. Gusset plate, this is the main channel section, and these are the lug angles which is used for the joint. Sorry. We have the channel section like this, right? We have the channel section like this. What we are doing, we are using one lug angles. Okay, this lug angles is connected here with the channel section and connected here with the main as per